Okay, guys, thanks for joining the session. Looking forward to talking with you guys about a hot topic in K-12 in the last 3 or 4 years. And we've got some expertise, and hopefully we'll be able to convey that to you. Too bad we're not in person and can't really take a lot of questions, so we'll try to cover the content and try to keep it as relevant to like what is the decision-making process around whether to stick with a three-tier conventional architecture in your data center or whether hyperconverged is a good fit or a good idea or something to explore for the school district. Trying to be as relatable as possible, we'll be talking mostly about the use cases in a smaller, middle-sized school district. So that'll sort of be the framework. My name is Derek Blakesley. I'm an account director for K-12 and high ed at PDS and starting my 8th year. So been doing it a long time and have had a lot of these conversations with school districts. And most of those conversations, I've included Tim Williams, who's one of our senior architects and really specializes in the data center and specializes in the architecture and the planning and the implementation around server storage and hyperconverged solutions. So I'll have Tim do most of the talking. He's the expert. He's the one you guys are here to learn something from. And what we're really trying to do is break this down into what are the possible avenues you can explore. There's kind of been a split in hyperconvergence in the last year, according to Gartner, where they're really focusing on the software side of it and what that can do. But we also like to talk to customers about the outcome that they're looking for from a manageability perspective, from a simplicity perspective, and even around support and things like that. So looking at the agenda, and then I'll hand it off to Tim. And I think Tim's been doing this for well over 10 years. So I really appreciate his insight always in talking to customers and in settings like this. Let's look at what is hyperconverged infrastructure, start from the beginning, what it can do for you, what it can do, what it can't, and then what it enables, not just from managing your data or holding onto your data, but where it can move it in order to keep it safe and how that works. What problems does it solve? Why does it really exist? What benefits is it bringing? What it can do for performance? How do you update the stack, or what does it look like that's different from traditional three-tier? Support, and then of course, hot topic for everybody, especially K-12 with ransomware. How does it contribute to a overall security posture that the district can feel comfortable with, from levels of leadership down through the tech team, and with the folks whose data that we're entrusted to keep, the students and the teachers. So with that, I'll hand it off to the expert and the star of the show and of the session, Mr. Tim Williams.
Hey everybody, my name is Tim Williams. As Derek said, I'm a solutions architect for the business data protection team. I do a lot of, I have a heavy focus on hyperconverged infrastructure options, as well as disaster recovery, server storage, etc. So the purpose of this is to kind of, as Derek said, is to just give you an overview of what hyperconvergence is, kind of an HCI 101, maybe give you an idea of a technical outline of how at least one particular vendor stores it. And handle storage protection when it comes to hyperconverged as opposed to a three-tier. We'll talk a little bit about what we can do with it, the choices you get to make, and how that fits into your overall system architecture and business drivers that are making the difference in your 2021, 2022 initiatives, et cetera. So first to talk about is just what is hyperconvergence, just the basics of what it is. And it's the culmination of the software-defined data center. It's, in fact, this is something Gartner has even made changes in the last year, and we'll talk about that in the next slide. But they've actually kind of redefined hyperconvergence as opposed to just having your drives in the servers and having that be re-architected back to the hypervisor. It actually is been redefined to be driven by software. It is no longer a hardware-driven solution. It cannot be hardware-driven to be technically HCI by the market. Now, that doesn't mean that there aren't solutions that are very similar, that they give the same benefits to hyperconvergence, that technically don't fall under that. And we talk about that as well as part of this presentation, because it's not about the literal definition of hyperconvergence. It's about the value it provides and how it can help you achieve goals in your management of your network. Typically, one of the big keys, though, to HCI is that everything is supported by a single vendor. This allows you to call one person first. Now, sometimes, depending on how things are architected, depending on dependencies, there may be people that there are warm handoffs to other support staff. Sometimes there's applications that are higher level within the ESXi stack that then wouldn't be handled by the hyperconverged vendor. But in general, that's kind of where it falls. And that's the main goal of hyperconvergence, is that single vendor helping you aggregate everything together. So the big problem that we have, especially in K-12, is you have not enough people and not enough expertise to handle extremely deep knowledge or complex processes around managing your data center. So it's not a problem. That's just the way it has to be. There just isn't enough people. There's too many users. There's too many teachers. There's too many students. There's just so many things going on the networking side with wireless and wired control, with ClearPass having to do things to manage the network and protect the network, that you simply don't have the time to dedicate resources to be able to fine tune dedicated storage appliance, or work with fiber switching that is set up a specific way, and you have to manage each of these components in separate ways. None of that is all integrated when you have the legacy way that we design infrastructure and the way that we architect it. And that in particular, K-12 is a problem, because people are spread too thin. Everybody wears lots and lots of hats. I'm guessing most of the people watching this wear at least 3 or 4 hats. Nobody is dedicated to servers. Nobody is dedicated to storage. That only happens in large enterprise, where people can actually silo into groups. And if anyone's ever worked with Microsoft support, you see the consequences of that is that you can't get somebody who can help you across multiple technologies. They're helping you with that one thing. You call them in with a desktop issue, they will only look at desktops. They won't entertain a server troubleshooting problem. They won't pass it off. And that's the problem that we're trying to solve, is integrating that and making it simple to manage. There's other things in terms of CapEx investment. So when you do a 3-tier architecture, when you do a legacy, storage appliance, they don't quickly scale. Now, some of this is changing. The market has met this, and we'll talk about one of those solutions as well with the legacy 3-tier. One of those solutions has met that with that quick scale out and easier to expand storage than it used to be. But in the past, you had to plan for all your growth for 5 years up front and purchase all the disk right away, or you would be hurt in the long run, because you would have 2 separated groups of disks that wouldn't be able to work as efficiently as possible. We talked about the people thing. I was talking about it right there. So first thing first, let's talk about the Gartner Magic Quadrant. So this is kind of if you're not familiar, is every year Gartner does an evaluation on just about every technology. They group and they evaluate specific vendors that fall under it. In the HCI world, there's really only 2 players right now, Nutanix and VMware. VMware vSAN is grouped in with VxRail, if you've heard of that, the EMC VxRail. Those are essentially the same thing. It's just vSAN, except EMC does some automation on the front end. So there are other players, and all of these other ones, the scale computing is kind of a Nutanix AHV light. Pivot 3 StoreMagic is kind of the replacement for Left Hand, which was Store Virtual VSA for HPE. They all have niches, but most of them are all kind of based around the same simplistic, we're just going to mirror your data, and it's not really very intelligent. The solutions that are actually applying intelligence and up the stack capability, it's Nutanix and VMware. So we're going to focus most of this on the 2 primaries. We'll talk a little bit about Microsoft. We'll talk a little bit about what HPE has also as kind of the counters. one of the things that's noticeably missing from here is SimpliVity from the previous years. And the reason we talked about why they dropped it off, and it's because there's a hardware card in SimpliVity, and it's therefore somewhat hardware defined. And then technically that makes it not HCI according to the definition on the market. However, the solution still functions very much the same way. And we in fact have multiple clients running SimpliVity for their HCI benefits. So who's the leaders right now? We talked about Nutanix. They are the leader. They are the first that entered market with the HCI type solution. They developed the scalable RAIN distributed architecture that we'll be talking about. They're the leader in this stuff. They have solutions that fit very small businesses as well as the large AWS class enterprise capabilities. They scale better than any other solution on the market right now. It works with, you have your hypervisor choice, you can do hybrid, all flash. You get some data reduction in hybrid, which is a unique thing. Nobody does data reduction in hybrid except them and 3-tier solutions. It relies upon RAIN, which is an array of independent nodes as opposed to an array of independent disks. So you treat each component of Nutanix, each blade, each in the 4-pack, you treat each of them each as an independent node, and you distribute your data across nodes as opposed to across disks. There's a lot of different applications that Nutanix offers as well in their cloud and on-prem ecosystem for network control, as well as cloud implementation, et cetera. Another one we like to talk about, and this is kind of the counter to, it's the HCI benefits without integrating it directly like that. So, and most people here are probably familiar with Nimble, at least as a storage appliance. It's a SAN. They have created an offering now that's kind of an integrated hosts, switching, and Nimble storage appliance that's managed all from within VMware. So this means you get all the benefits of HCI. You call HPE for your issues. They direct you to the right place. You're going to work with the people you need to work with. You're going to get integrated support. You get all the benefits of Nimble's incredible software intelligence. And you get all the single pane of glass from managing, because of the Nimble plugin for vCenter. You can manage your Nimble from vCenter. So you end up with all the benefits of HCI while still being able to kind of tweak and gauge your storage architecture as well as your switching. You can kind of have some of that tuning and customization that you might have that you might not have with an HCI solution. Similar, we talked about VMVxRail. The big differences here is they use disk groups. There's the way that they store data is a little different. They tie, so most of these other ones rely upon what's called a controller VM, and we'll talk about that in a sec too, to actually redistribute the storage back to the hosts after applying intelligence to it. In VMware, that is directly tied into the host kernel. So this means basically you check a box and you have the vSAN capability is there. Now, there's some benefits and there's some drawbacks to this. The reason I like a CVM better is because a CVM allows you to update the software for the storage without having to take down the entire node. Because it's tied to the kernel, when you update vSAN, you got to take down the whole node no matter what. If you update anything, the whole node has to go down. And I'm not as big a fan of that. But it's all about priorities on your updates and how comfortable you are with it. VMware, as I'm sure many of you, has a vast array of applications that it can work with. vRealize, they've got Network Insight, they've got all sorts of other things that VMware does. They've got ties to AWS and Azure. So VMware has that story. That's their story, is that they control that. Frequently, though, it is the most expensive option. If they come in low, it's because they're going to gouge you on the back end. It's just our experience. The last thing we talk about, and this was the one that was the only one that wasn't in the niche players, is the Microsoft. There's kind of they have two different solutions in this. There's the Storage Spaces Direct, which is the build your own HCI. You're plugging in disks, you're configuring it yourself. There's no automation. There's none of the intelligence. You're just plugging disks in and you're configuring it and you're playing. It's build your own HCI. It works. There's even some pretty cool functionality with direct memory access. Microsoft obviously they do everything. They have at least some solution in just about everything. And like I talked about before, though, the support is rough. There's very little automation, and it's tied to Hyper-V style stuff. So anyone who's worked with Hyper-V knows that there's challenges there too. You get what you pay for when you go free. All right. Oh, and to mention too, Nutanix, they have their own, and we'll talk about this too, they have their own operating system called Nutanix Acropolis Hypervisor, which is what enables them to be a single pane of glass for everything. All right, so how this works, 3 tiers. So this is the big thing I like to talk about is 3-tier versus HCI. And one of the things that really makes a difference is the number of hops to make a read. And so your read performance, so in a 3-tier architecture, even if you have a cache on the SAN that's ready with SSD and it's got the data you're looking for already ready, you still have to go from the host to the storage fabric to the SAN, and then back to the storage fabric and back to the host again to do 1 read. So you have 4 hops, which means increased latency. It means increased risk of failures, of congestion, of any sort of problems. And you also have to manage each of these tiers separately. The SAN is managed by a specific tool. The storage fabric, which is either like iSCSI switching, fiber channel, NFS, those are all managed independently, as well as the host, which is going to be VMware, Hyper-V, et cetera, Zen server. Those are all managed independently, of independent tool sets, and you have to know each of them, how they interact. And when you call for support on one of them, they're going to blame the other 2. And then so you call VMware, they blame the storage. You call the storage, they blame the fabric. You call the fabric, they blame the other 2. And you end up with, it becomes a complicated support situation. The HCI model on the right here is basically you just have your hosts. They pool together, they talk to each other, they share data directly to each other over the production network, and they allow you to take local reads for every single bit of data that you read. So when you have anything that needs quick storage performance, or you need anything that will be reduced, that will be affected by latency or availability, will be reduced because you're going to be able to go right over the local bus, 0 hops. You don't have to go, you're not going out to another host, you're not going to a storage thing, you're not going through a fabric, you're just looking right over the local bus directly into the data, which is really, it's a very impressive system in terms of its ability to manage and move data quickly. So that, and the redundancy comes from just having multiple copies of the data across nodes. So let's talk about how it's actually designed, the premise. So on this here, you can see that there's a CVM on each of these nodes. So you have your independent nodes. There's 3 of them, and each one has a CVM, and it creates a container where it pools the storage available from that host and adds it to an aggregate pool for all of them. And then it will distribute that storage back to all the hosts to be available as a single data store. So when a VM is written to node 1, so let's say you've got, your we'll call it a domain controller is running, on node 1, it's going to have a full copy of all the data of that domain controller running on node 1, so it can do local reads and writes. Now, the second, like in any storage situation, you're going to have the second write is going to have to cross nodes, which is why I didn't talk about writes being different in the previous slide. But you'll have a read that comes into node 1, it'll read it and send it out. If you have a write, and it'll create a second copy of whatever is written across all the other nodes. So you'll end up with 1 full copy on node 1, and then you'll end up with chunks of data across all the other nodes. So what this means is that if you lose a node, so let's say you lose node 1 and the domain controller fails over to node 2, while it will have at least some of the data from the domain controller, it will then pull all the data from the other nodes at the same time to rebuild that copy. So what that means is you can actually saturate the bandwidth across multiple nodes and create 4 or 5 streams of data to rebuild data very quickly. In a legacy way of doing this, which was RAID, you were dependent upon one thing having a copy of the data, which means if you have other HCI architectures, will just create clones. And so when you have we don't have it distributed across multiple nodes, you end up with a single path. So one node will have to do all the rebuilding across the network at once. So it'll have to saturate that single node and the node that's receiving the rebuilds at the same time. So you end up with more bottlenecks and a slower process to rebuild. RAID as well is dependent upon checksums and digests that require a lot of I/O just to rebuild a single node. When you use RAIN, which is this architecture, you're just pulling a copy over and you offline the failed disks, or you offline the nodes. When they come back, they're just added back to the cluster. There's no rebuild for bringing data back. It's just, you just have 2 copies of the data everywhere at all times. And that's how you create protection. So it's important though with this that there's a lot of intelligence, which is why a lot of these solutions run by software, is because they require so much intelligence. It also enables, because of the nature of the way the data is stored, you can create DR scenarios very easily as well. So if you have 3 nodes in a production cluster, you can have sometimes even a single node that just receives snapshots of that data, or you can have a 3-node cluster, which is what we'll talk about when we get to some of our examples, that just runs you just have all your data shipped as deduplicated, unhydrated snapshots. They run, and then you can boot up your data on the DR side instantly, and it's all natively integrated to the storage network. You don't need to own a Zerto. You don't need to own a Veeam. You don't need to create complicated DR scenarios. All that stuff is handled underneath the hood by the HCI vendor's software. All right, so we talked about this a little bit, so we'll be real quick, is what are the goals of this architecture? It's scalability and it's simplicity. So you want to be able to have building blocks, right? So you have a certain amount of workload that works on a certain size of node, and you basically chunk your network and your requirements into X number of nodes. And then as you grow, you can just purchase another node. You just bring that node into the cluster and it's ready, and the resources are available. You've got more CPU, more memory, and more hard drive, more flash. All of that is just directly integrated as part of your expansion, and it's automated and maintained. It's about choice. It's about being able to make decisions about what you're doing. And it's about being able to centralize and manage everything from one place. So that's simplicity and that's scalability. Where HCI doesn't play great, there's nowadays everything kind of can run on HCI. There are some things that just don't, and it's mostly due to the nature of having single nodes. So if you have one VM that's huge, like a file server, some places have 20 terabyte file servers, and all their other data takes up 4 terabytes. So they have 4 terabytes of just random servers running small applications, and a file server that's just a huge honking mess. And in order to size for hyperconverged, you have to be able to fit that big single VM on each node. And then it also will create a second copy of itself across the others. So you end up using essentially 2 full nodes for a single server. It's inefficient. That's where 3-tier becomes a better play, because you can customize and tune that specific workload that's really big to the storage in the back end. And it's not managed it's not reliant upon an array of nodes, that some of which may not even do anything. Or, basically you're creating just a redundant node that does nothing. That's not a good architecture either. This is the same idea too behind the simplicity, is you want to have the software OS that works everywhere. So instead of having disparate technologies and disparate management systems for each of your cloud, on-prem, your software, et cetera, the idea is to have one software underneath that manages the architecture itself. So that data is essentially containerized and can move from system to system, including the cloud, very easily. So that's where Nutanix and VMware separate themselves, as well as Microsoft. They've got the Azure Stack can do some of these things. Is they have true portability of their data to different cloud infrastructures. So you can quickly go from a VMware cluster running on Nutanix or an AHV cluster on Nutanix. You can quickly integrate that with a cloud available cluster with a Nutanix clusters, it's called. VMware has direct hooks with AWS, et cetera. And because VMware is the market leader in the hypervisor services, so everybody has to work with them. And that's kind of where HCI starts to develop that's this extreme scalability. It may not apply too much to K-12. You do have a lot of cloud services. Most of it is Google based in most environments, but there are some scenarios where you may end up using cloud as a DR destination or something like that. And everybody and all these HCI vendors work very well with DR cloud solutions. So hypervisor choices. Now, there's really in most people's world, there's really only two options. There's things like Citrix Zen server. There's some black site, there's some KVM stuff. People will do custom KVM, which is a little bit here. The Nutanix HV is actually KVM, which is the open source hypervisor. It's a hardened and expanded upon capability. It's basically they put a GUI in front of an open source hypervisor. And so AHV has that capability of kind of integrating with anyone that runs KVM. For example, AWS all runs on KVM, which is the open source hypervisor. Now, they've done a ton of custom dev on it, and it's not the same that you would get when you just download it from Debian, but it is that same architecture underneath. The VMware ESXi, which is the one that we are all used to, every one of us who's been an administrator in the last 15 years has worked with ESXi in some form, whether it's just a standalone host running a few VMs or a large scale cluster. Everybody's worked with it. It works great. It's got a ton of market share. It's got a ton of available resources online for troubleshooting yourself. They've got everything because they've been the market. They have been the market leader for life. It does have a problem in that it gets very expensive. It's essentially the VMware tax is a thing that people are really worried about every year, because the more you basically pay 25% of whatever your licensing cost is every single year. So you're going to end up paying all of your VMware costs again every 3 to 4 years. Where the Hyper-V is kind of a competitor to that in that it's integrated with your Microsoft. So a lot of people have their Microsoft, maybe they have data center licensing so they can provision any number of VMs. They will include that and they'll run their data center on Hyper-V simply to avoid that VMware tax. Hyper-V has a lot of challenges in that it doesn't work well with iSCSI. Anyone who's it's really designed basically for fiber channel environments and clusters or very small clusters. It can work very well. When you use storage spaces direct, where it's Microsoft provisioning to Microsoft, and it's doing it without bringing in clustering or the iSCSI initiator, that's where it can be a little more robust and capable, but it's still like you get what you pay for on Microsoft. The support is not great, and you end up with complex management and troubleshooting operations. That doesn't really simplify and make it easier for your end user, your administrators who are trying to wear 6 hats. They have to know Hyper-V in and out, and to troubleshoot it, they have to be able to Google various strings and search event logs themselves and know what all those things mean. It creates complexity. Nutanix AHV is now included with Nutanix operating, if you purchase a Nutanix for your storage, and that can be it doesn't have to be their branded. It could be HPE, it can be Dell, it can be Lenovo. It's included with Nutanix, and it gives you almost all the functionality of ESXi. There are a few things tied to the Enterprise Plus capability in VMware. So like if you do distributed switching, if you do NetFlow type stuff, that is not there in AHV yet. They're working on it. Open vSwitch has a lot of capabilities. The problem is they have to wrap it into what they do on the back end. So basically, if you're not using a lot of up the stack VMware solutions, such as Horizon, such as VMware vRealize, or network insight, those kind of things, those up the stack VMware solutions, AHV will cover everything you need. They originally had problems with backing it up. Like there was nobody supported AHV directly. Now, almost every major backup vendor has the ability to directly interface with AHV and perform snapshot level backups. So like, I'm suspecting a lot of you who are watching this have Veeam already. Veeam has full integration with AHV. You have to do the universal licensing as opposed to the socket-based licensing. We talked about this a little bit. What can run on HCI? At this point, I have a hard time not just saying anything. Like SAP HANA has even already certified Nutanix running ESXi. They have not certified AHV, but they've certified Nutanix running ESXi, and that's a very large data science, big data application with tons of I/O and complex data storage capabilities, and that can be done on ESXi running on a hyperconverged solution. So the reality is that you can run just about anything you ever want. You can do Kubernetes stuff. You can do Docker. You can do container-based application dev. You can run complex database workloads. You can do just general workloads, which is what most people are using it for. You can run anything you want. There's not a lot of restrictions. The big thing to note is just if you have that one monster VM, it's typically inefficient to put it on HCI. It'll still run, it's just inefficient. So a couple of use cases, and Derek, you might want to chip in here as well. We did a couple of things this past year. We did a lot of Nutanix and SimpliVity. We wanted to highlight a couple of real successes we feel that helped a lot. Verona put out an RFP. They are a non-VMware. They're not going to do VMware. So it basically we got to be Hyper-V, we got to be AHV, we got to be Zen Server. They had old unsupported infrastructure. It was disparate. They had lots of different systems running different things. They had multiple different systems to manage. They had a DR requirement. So there had to be, as part of this, there needed to be an integrated, simple DR plan. And the administrators are, like we talked about, they wear a lot of hats and they're not focused on managing data center. Their network is far more important to them and to their users, far more noticeable than their backend infrastructure, because they use Google for a lot of things, but they have some systems that have to run on site. So what we did is we put dual 3-node Nutanix AHV clusters. So they have one across campus and one on their primary data center, and they do active DR between the sites, allowing them to achieve a sub 1 hour RPO where they ship snapshots. They can ship snapshots every hour, and basically anytime if they ever need to fail over, they can do an active failover to their other clusters in between the two, and the data will continue to work. It'll continue to flow. The virtual machines will continue to work. Those protection policies are designed to be pretty flexible. As well, all of that, because they do have the two separate clusters, they can manage all of that from a single pane of glass with Prism Pro and Prism Central. And so you have the ability to manage all of your data through a single management cluster across multiple data centers, across DR environments. And it was done without having to use the industry leader of ESXi or any third-party tools.
Yeah, if I could chip in, Tim.
Yeah.
One important thing, there's probably a lot of you watching this and be like, well, that would be great to put in a production and then a mirrored cluster, but their money's not there to do it. And I think it's difficult in data centers because we don't have the E-rate funding in order to supplement the investment. So keep that in mind, that Hyperconverged also does allow you to put that into production, and we can repurpose or use other capital equipment or equipment that's already capitalized on to put together a backup plan. And things are now, as Tim's mentioned many times, tying into the cloud. We can take as the foundation of production HCI and explore a lot of different options for backup and DR. So I know sometimes the money is tight. So if you've got if you've got a referendum or something like that, and a good driver, investments can be made that are a little more like the Verona use case. In other cases, it's a little more like Mauston over here or some of their other districts where you're going to use different hardware and some software to put together a more robust backup and DR strategy. So just wanted to add that in. There's lots of ways to look at, a lot of ways to peel the onion and get to the final solution on some of this stuff.
And then so Mauston had another use case, and this is where we talk about the lots of hats, especially is Mauston has they have one technical administrator for the entire district, and he's responsible for everything. They had their hardware that was in there was it was configured. There were some configuration issues over many years of just trying to keep it working. There were some hardware failures, some technical failures within there that were out of their control and couldn't be fixed. And they have the costs of VMware, et cetera, the unknown configuration. So we installed Nutanix with ESXi, which allowed us to do a very simplistic migration. It was just a straight cross-cluster migration. We had to get a vMotion network working. We simplified the clustering environment and their storage management. Now that's all just integrated within Prism Element if they choose to. We gave them simplified and very capable support with them being able to call Nutanix directly and get immediately on the phone with a level 2 or level 3 resource. The people who answer the phone will be that. And that's what you get when you do this integrated support type contract, is you get that single number to call and you get the resources that are a little more capable right away, because they're dedicated. They have to know lots of things. They can't just be specialized on one target. They have to know everything and they have to know how it works. So they can't be level 1. And now a single IT resource is managing hundreds of students and staff. They're no longer in a position where they can't get things done on the infrastructure, or they have to do patchwork just to keep it alive, because now all that stuff is handled on behalf of them. And so what a lot of these things do is they will come with, and many of you probably already heard of the call home functionality. Depends on, they call it different things on different vendors, but all of them have their own integrated phone home type technology that will proactively monitor and notify you if there's a problem. Frequently, they will notice it before you do. And then they will either send you the stuff you need to replace it and call you and engage you to do support in advance. You don't have that problem that I talked about where vendors blame each other. And that's a thing that really likes to happen. And especially if you work with like a VMware host on HPE and Dell storage. You end up with these two vendors that don't like each other blaming each other. And you're just caught in the middle, and the whole time your production system is down, and it's just not worth it. Get rid of that. Get your pooled resources, get software in front of it, let the software handle it, and the software vendor is able to support the whole thing. So as far as security goes, all of these systems have at least some bit of security hardening within them, right? So ESXi there's always patching to be done. People are noticing vulnerabilities. One of the advantages of using what I would call is non-market leaders. So for example, in Nutanix HV it's the Apple effect. So people didn't target Apple systems. They always like to talk about, oh, Apple, they don't get viruses. Well, they could, but nobody was writing them because the market was so small. It was less than 5% of endpoints were Apple. As Apple grew, people started targeting more. But you have that Apple effect with these, is that you have, if you use something like a Hyper-V or a HV, you have that kind of security through obscurity, as well as having their dedication to resolving things too. So for example, Nutanix HV was actually developed for the Department of Defense because ESXi was not considered, the standard branded ESXi was not considered secure enough. Now, Nutanix said they were willing to develop the necessary security functionality, and VMware wasn't. So that was kind of how HV came to be, and that's why we called it a hardened version of KVM, is because they're very security focused. In terms of resiliency, all of these types of solutions will be able to lose a node, lose a disk, lose multiple disks, lose multiple nodes, depending on how they're configured. But they all have resiliency across every single component. There's no single points of failure anywhere. In terms of ransomware protection, lots of these softwares have either optional or included analytics platforms that will notice ransomware activity and notify you in advance or shut them down. For example, if you've ever worked with like a Cohesity or a Varonis, they have those integrated data management platforms that will notice these. They will monitor these things. All these vendors have that capability. They also have versioning underneath the hood. So you have snapshotting and versioning under the hood that allows for quick rollback and protection against underlying data being overwritten. So you don't have, if you lose the one copy, you still have the ability to revert back. And RAID and RAIN, we've already talked about those, so I won't go too far into it. It's just the nodes versus the disks. All right, so this is just some of the stuff that the enterprise grade. So a lot of these things were designed for enterprise grade stuff. So for environments where people are constantly under attack, like any major corporation is constantly being attacked by China, by Russia, by random hackers. It's just the way it is because they have important data. And the benefit is that their investments into that security trickle down to you because the software has to be developed to protect them. And therefore you can get the same software and get the same benefits. So there's all sorts of self-healing capabilities. You have the ability to encrypt via software on a lot of these. You don't require self-encrypting drives or external key management. They have that capability into them. They have the ability to tier data for performance. They have offsite replication. So for example, Xylete for Nutanix, where you're just getting a DR cluster in the cloud. You have the ability to put in STIGs. So if you're familiar with that, STIGs are basically specific security fixes that are chosen. Many of them are done automatically, but sometimes you have specific requirements and specific regulations. You pick a STIG and there's actually already an automated playbook that will apply those specific configurations in the background for you, which is a nifty little thing that Nutanix HV and VMware ESXi have. You have the ability to lock down your clusters for client authentication as well. That's what cluster lockdown as well has. So in conclusion, the big thing to note and remember about HCI is that it's about simplifying. And it's in the K-12 market, in the SLED markets, it's really trying to reduce the amount of time that your admins spend on managing software and managing their data center technology equals more ability to deliver directly to the students, to the teachers, to the important people. They don't have to spend as much time monitoring it. They don't have to spend as much time maintaining it. They can focus on delivering the visible solutions that you want them to be project oriented, to be focused on developing future technology, developing future state, as opposed to reacting to existing issues.
Yep. So I'll just wrap up. Any questions? Do it for yourself, and it doesn't cost anything. Have a conversation with one of our architects, or give us a call. We tried not to make this too much of a commercial. I think Tim did a good job of kind of just laying out the market and the use cases. So, but that's our job: is come in and try and solve these business problems and get you the optimal solution. So, give us a call if you want to follow up, and hopefully the rest of the virtual conference goes well. And thanks, Tim, for your time presenting everything. Thanks, everybody.